Welcome to Git Push Sit Back, where we'll explore how Flux powers a managed GitOps offering on Azure. As Francesco introduced, I'm Dipti Pai. I'm a software engineer at Microsoft, where I primarily work on Azure Arc-enabled Kubernetes and our GitOps offering. And also, I'm a maintainer of the Flux CD project. I'm really excited to be here today. It's my first time at KubeCon. It's the first ever FluxCon. It's obviously my first time talking here, so lots of us, and yeah, definitely really excited. This is the agenda that we'll be covering today. We'll talk about various aspects of the GitOps offering on Azure, and we'll also have a demo around deploying Flux at scale in Azure, and also some Grafana-related monitoring integrations that you can enable. As we've seen with all the presentations this far as well, Flux is the foundation for automated continuous delivery platforms on Kubernetes clusters. Across its extensive set of CRDs and controllers, it provides support for a variety of sources like Git repositories, OCI repositories, buckets, and it supports several templating types, Helm, Customize, YAML. It also provides a rich set of it's action-packed with features like notifications, image update automation. So it really provides a really solid base and foundation for your automated app delivery on Kubernetes clusters. However, as large organizations begin to scale their Kubernetes clusters across hybrid and multi-cloud environments, certain questions and challenges begin to arise. How to deploy Flux at scale, how to do so in a seamless manner across these different varied environments, how to measure compliance and governance of your Flux installation, how to maintain a CVE-free, secure Flux installation. So the Azure GitOps offering intends to address all of these challenges while leveraging and building on Flux to deliver the automated continuous delivery platform. We'll explore each of these, starting with a unified GitOps offering with Azure Arc-enabled Kubernetes. A quick show of hands, how many of you all have heard of Azure Arc here? Okay, yeah. A lot of y'all. So for those of you who might be new to Azure Arc, it's a key piece of technology in Microsoft's adaptive cloud strategy. It is a family of products with a key goal to extend Azure's control plane to resources that might be outside of Azure. So this is there for VMs and Arc-enabled Kubernetes clusters. Is enabled by Azure Arc-enabled Kubernetes. So with this, you can have your Kubernetes cluster that is hosted anywhere. It can be on the edge, on-prem, in your data centers. It can even be in another cloud. The Kubernetes cluster can be running any distribution of Kubernetes. As long as it's a CNCF certified Kubernetes cluster, you can run a simple command against the cluster and have it projected as an Arc-enabled Kubernetes resource. With this, you can have a central control plane to view the inventory of all your resources that are hosted in Azure natively, like Azure VMs, AKS clusters, and you can have the same resources that are there on-prem or outside of Azure appear in the same single control plane. And with this, you can also apply GitOps in a unified manner across these different clusters hosted anywhere. So this is Azure GitOps process of setting things up at a high level. So you can start with any Kubernetes cluster and Arc-enable it, or you can start with an AKS cluster that is hosted natively and managed completely in Azure. From here on, you set up Flux as a cluster extension. When you do this, you get the Flux upstream CRDs and controllers, along with a couple of Azure GitOps controllers. And then you associate Flux configurations. These let you associate your sources, like your Git repositories, your OCI repositories, and your customizations with your Kubernetes cluster. So I said that Flux is installed as a cluster extension. So I quickly wanted to touch upon what a cluster extension is. Well, as the name indicates, a cluster extension extends the capabilities of your Kubernetes cluster. But the important aspect here is that it provides an ARM-driven experience to do so. ARM stands for Azure Resource Manager, and this is the resource model for resources that are hosted in Azure. So this provides like a REST API interface for you to interact with Azure resources. Cluster extensions also build upon the foundation of Helm charts, so it provides those really robust lifecycle management capabilities for your applications. They also provide enhanced cluster management tools like Container Insights and Azure Policy for governance. And we'll look at Azure Policy a little bit in detail a little later on when we have the demo with deploying Flux at scale. So Flux is implemented as this cluster extension on Azure. So we started with the cluster. We either Arc-enabled it, and we set up Flux as a cluster extension. The last step to complete this process is to set up Flux configurations. This allows you to associate sources and your customizations with your Kubernetes cluster. Just like the cluster extension, the Flux configuration also provides an ARM-driven experience. That is, you can interact, configure, and manage your configurations using Azure APIs. When the Flux cluster extension is set up, there are two additional controllers that get installed in your Kubernetes cluster. One is an Azure GitOps agent that watches Azure for new or updated Flux configurations submitted in Azure, and it creates Flux configuration CRs for these in your cluster. A second controller watches these CRs and creates upstream Flux CRs like Git repository specs and customizations. And from here on, the Flux CD controllers take over. The Azure GitOps agent also reports the status of the Flux resources back to Azure. So because of this ARM-driven experience, an Azure user who is already familiar with Azure tooling, already uses the Azure environment for setting up other resources, can use any of the tools and experiences that they're already familiar with to set up Flux as a cluster extension and configurations. So for example, an Azure user can use one of these several options like Azure Portal, Azure CLI, PowerShell. They can use SDKs in several languages like .NET, Java, Python, Golang, you name it. They can use infrastructure as code templates. They can use Bicep, ARM templates. So there are like a variety of options for setting up the Flux cluster extension and configuration. You just need to choose what works for you in your environment, and there is a way to configure it. Because of the bidirectional communication established with the agents on the controller, not only can you use these tools and experiences to set up Flux extensions and configurations, you can also use it to monitor the status of your cluster extension and the compliance status of the Flux configurations. You can further zoom into the Flux configurations to view the sources and customizations that were applied and any top-level reconciliation status and failures. So this acts like a good first level of UI for, there are a lot of times like Kubernetes clusters and GitOps are deployed in environments where the users are not so Kubernetes savvy or tech savvy. So it provides them like a good first level of debugging related information as well to figure out what's going wrong if something is in a failed state. This also enables rich visualizations, for example, Grafana dashboards. And I've not mentioned it here, but I think the topic of MCP server came so often. So because Azure has an MCP server, and these Flux extensions and configurations are set up using Azure APIs, it natively integrates with the Azure MCP server, so you would be able to query the status of your extensions and configurations inherently as well. So that the diagram here puts together everything that we've been talking about so far. The big box at the bottom is your Kubernetes cluster. It can be on-prem in another cloud provider. It can be a natively managed cluster in Azure. We'll start at the top left. So a GitOps user can use any of the tools that they're familiar with to do a put of either the Flux cluster extension or configuration into Azure Resource Manager. This goes to the Kubernetes configuration, RP, and data plane service. And from here on, the agents in the Kubernetes cluster work together to pull the Flux configuration down to the Kubernetes cluster and convert it into Git repository and customization CRs. From here on, the Flux CD controllers do their magic and sync with your artifacts, pull them from Git repositories, OCI repositories, buckets, and deploy those customizations in the target namespace. Okay, now that we covered the process of setting up the Flux as a cluster extension and Flux configuration, I wanted to highlight how we would do this at scale with the Azure policy. So for those of you who are new to Azure policy, it allows you to specify definitions, and then these policies can be applied at a desired scope. The scope can be a management group, a subscription, a resource group. Once the policy is assigned, whenever new resources come up in this scope, the policy is automatically applied on the resource. And you can also view the status of the policy, the compliance status of your resources at scale, and also apply remediation tasks for any non-compliant resources. So with this, there are like built-in policies for Flux as a cluster extension and for deploying Flux configurations. So with just a one-time assignment, you would be able to deploy Flux at scale across your Kubernetes clusters. So next, I'll be demonstrating this deployment at scale with Azure policy. In this demo, I've used a single pre-created cluster in my AKS resource group, but just imagine having a fleet of clusters across your hybrid environment, some on-prem and Arc-enabled, some in another cloud, some that are natively hosted in Azure, and having a single policy to set this up. Okay, so here I have a resource, AKS FluxCon NA demo, in the FluxCon NA demo resource group. If we go to the settings extensions page, we see that currently Flux is not installed as a cluster extension. If we go to the GitOps page, we see that there are no Flux configurations. Next, we'll go into Azure policy, and we will filter the definitions by Flux. We see that there are a number of inbuilt policies. We'll choose the last one, which configures the Flux extension on the Kubernetes cluster. Next, we'll assign this policy. Recall that policy assignments are made at a desired scope. So here we'll choose the scope of the policy to the resource group that had the AKS cluster. Yeah, then these are some of the default parameters. Excuse me. Here you can configure your Flux extension and create a remediation task. This applies the policy at scale to all your resources which are already present. We then create the policy, and the remediation task gets created automatically. If we go back to the policy assignments page, we'll see the new policy that we just created. We can then view the compliance status of this policy. If there were a number of clusters, they would all appear here at scale. Currently, the cluster is non-compliant, but if we go into the resource and back into the extensions page, we'll see that the Flux cluster extension installation is now in progress. After a while, the cluster extension gets installed successfully, and the resource goes into a compliant state. Next, we'll repeat this process to set up a Flux configuration. Again, we go back to the definitions page and filter with Flux. We'll choose one of the Flux configuration policies. Assign this policy again at the FluxCon NA demo scope so that it applies to our AKS cluster. And here we go ahead and configure our Flux configuration. So this is a one-time configuration. We give it a name, and recall that Flux configurations help us associate our Git repositories and customizations. So here we would give the Git repository spec, the Git repository URL, the branch that we want to sync. And if we wanted to do a specific path within the Git repository branch, then we can configure the customization as well. This time I'll skip the remediation task creation to show that we can also remediate a subset of resources that we want to. instead of all resources in a cluster. Again, if we go to the assignments page, we see the new policy assignment. And when we view compliance, we see the non-compliant AKS cluster. We can then create a remediation task. The remediation task lets you select resources at scale that you want to remediate. Once the remediation task is applied successfully, when we go to the GitOps page, we see that the Azure policy has started creating a Flux configuration. After a little while, once the Flux controllers do their magic, the configuration goes into a compliance state. We can further zoom into the configuration to see which Git repository and customization we applied. We can also get a view into the commit SHA that was applied by source controller, what was the revision that was applied by customized controller. And we can further zoom into or edit any of the properties of the source or customization. If we go back to the AKS cluster and look at some of the Kubernetes resources, we can see that the Flux system namespace has the Flux extension controllers that were set up by the Flux cluster extension installation policy. And similarly, if we take a look at the default namespace, that would have the pod info deployment that was set up by customized controller. Okay. Next, I quickly wanted to highlight how easy it is to enable Grafana dashboards for observability. We'll start by creating an Azure Managed Grafana instance. With Azure Managed Grafana, you can use system identity to make your dashboards access Flux extensions and Flux configurations in a passwordless manner. This can also work with any other Grafana instance with service principal authentication. So the first step is to create the Grafana workspace. Once the Grafana workspace is created successfully, we can go into the resource. This gives us the endpoint at which the Grafana application is hosted. So here we can go ahead and add an Azure Monitor data source. The Azure Monitor data source allows us to use Azure Resource Graph queries to query our Flux cluster extension and configuration resources within your Azure subscription. Now that this is added successfully, the next step is to go ahead and create our dashboard. So I'll say new dashboard, and here we'll import a dashboard using JSON. So this JSON file is available publicly in our Git repository, and I have linked to it in the presentation as well. We'll choose the Azure Monitor source, and yeah, so just with a couple of steps, we are now able to get an at-scale view of how many Flux extension installations you have across your subscriptions and resource groups, how many Flux configurations are set up, and you can also enable visualizations around charts around the number of non-compliant, compliant, and pending Flux configurations. You can also enable alerting rules to be notified of any failing Flux configurations to take action on those. Okay, let's talk security. So security is a fundamental necessity and undeniably a huge area of concern for a lot of projects that are building and running cloud-native applications. Maintaining a secure Flux installation is critical for all Flux users, but it's even more important in highly regulated environments and financial organizations. With the Azure Flux extension installation, the upstream Flux controllers are rebuilt using Azure Linux as the base image. Azure Linux is a lightweight distribution of Linux that has a smaller memory footprint. It boots up faster. It just has a smaller attack vector as well. With Azure Linux as the base image for the controllers, we are able to control the base set of packages that get installed in all of the controller images. And because of this, we are able to rapidly patch any CVEs and update these container images in the Microsoft Artifact Registry. The cluster extension platform also comes inbuilt with the automated upgrade capabilities. So a new version of the Flux extension is released whenever there is either a new upstream Flux CD project update, so whenever a new release is made in the upstream Flux CD project, or whenever features are added to the Azure GitOps controllers, or whenever there are CVE fixes for any of these controller images. So with automated upgrades, your Flux cluster extension installation is automatically updated to the latest version that is released, and it really keeps your cluster extension secure and up to date. So with this, the user doesn't have to manage their updates anymore, and it just makes the process of being up to date with the latest installation really hassle-free. For users who want to have more control over their versions, they can pin specific extension versions in their Flux extension. Just like we saw that there was Azure policy, inbuilt policy for Flux extension, similarly, there are a number of policies that are built in for enforcing additional organizational standards. For example, you can enable pod security standards on your Flux system namespace or other namespaces in your Kubernetes cluster. Lastly, I wanted to highlight some of the integrations that are present in the upstream Flux project. Almost every controller and CRD in Flux has integrations with Azure. For example, you can use Azure DevOps repositories for your Git repository. You can use Azure Container Registries as your OCI repository. You can push to AKS clusters, thank you, Matthias, as your target cluster from customization controller. So there are like the number of these rich integrations, and Microsoft Entra ID and Azure RBAC is enabled on all of these to grant access to your Flux controllers. In the last few releases, we've worked to enable Azure OIDC and workload identity to establish secure access to Azure resources without storing any secrets, just making the overall GitOps workflow more secure. So if you're interested, tomorrow Stefan and I have a talk. This is the QR code with the details for the talk, where Stefan talks about Gitless GitOps, and I'll have a demo highlighting the Azure OIDC integrations in Flux. Yeah, I think that was all I had. I think the key takeaways are like with the Azure Managed GitOps offering, how we can have Flux deployed in a seamless manner, consistent across without regard for the location of the Kubernetes cluster, how we can do so at scale, how we can have a secure installation, and all of these combined with the capabilities of the Flux v2 continuous delivery solution. The app delivery team can just focus on their core business logic and simply git push and sit back. Thank you.